atomic weight of elements, right? So elements are under the pure substances. Okay, so we are trying to dig the classification of matter. Okay, classification of matter composed of pure substance in a mixture, but we focus on the pure substance. And by the way, what is an element? An element is the simplest form of matter composed of one atom or particular atom, something like that. Okay, the point. So we're gonna directly to the most common and start with, for example, alkaline. Okay, alkaline. So the alkaline are, so let's take about, ano lang siya, lithium. Okay, lithium, mga palangga, makita, lithium. Oh gosh. Lithium. Lithium. So by the way, I will write the topic here. Okay. Atomic mass. Elements. Atomic mass and weight. Okay. So we have the alkaline. So let's take alkaline metals. Let's take let's say alkaline metals group 1A, right? Let's take lithium 6.94 gram atom. Okay? What else? It's going to be the sodium. So sodium is 23 gram atom. Okay, how about potassium? So potassium is 39.1 gram atom. Okay. So, okay, but actually in the group 1A, okay, we have also the hydrogen. Okay, the hydrogen. The lightest element in the planet Earth, hydrogen. So, atomic mass, atomic weight is 1.008 gram atom. Ganon. Okay. So, you can see it like that, mga palangga. Okay, now we go to the alkaline earth. Group 2A. Alkaline earth. Alkaline earth. Metals. So you don't have to memorize everything. Just choose which among them are very, very common. Okay? So let's say I will take group 1 and group 2A. I will take, for example, calcium. Right? Calcium, the atomic weight of the atomic mass is 40.08 gram atom, right? And I also take magnesium. Okay, magnesium is gonna be 24.9, something like that. Okay, 24.97, something like 24.9 something. Okay, or let's say based on my memorization, I think it's gonna be 24.30. Actually, there's too much numbers play around in my brain cells that I have to choose the most appropriate one. Because sometimes our memory fails, something like that. So, like listen, you remember. Okay, so it's gonna be 24.30. Okay, but actually, if you use also 24 point something, it will be okay. There will be less difference, difference in your computation, but it's better to be accurate, right? So it's gonna be 24.34 magnesium gram per atom. I said before 24.9, and then this 24.30 talaga siya. Okay? Or you can check that out also on the periodic table to make it sure. Okay, this is on the technique to make it fast, okay, during your calculations. And now we go to group 0, group 0, meaning the last. I think the number 14 in the group, if you count that one in the, in the left to the right, something like that, and it's gonna be 14. But then if you try to count from the right, it will become 0. Right, 0. And then from the left to the right, 14. From right to the left, it will become 0. But normally, it is common to be called group 0. Okay, so group 0, these are all the noble gases. Example, helium, neon, xenon, argon, krypton, and beryllium, right? Okay, so they are unreactive gases. Unreactive gases, or shall we say inert gases. Okay, so 3 terms: noble gases, inert gases, and unreactive gases, meaning they are all stable. They will never react to metal, something like that. Okay? But it depends on the situation, because beryllium is the excuse one, because beryllium will react to hydroxide. We have beryllium hydroxide, right? But the others will not react. Okay? You will never say argon hydroxide, there's no such thing like that. So only beryllium will, sometimes react slightly to metal, but under, few circumstances. Okay? Get the point. Now I must take only 2. Okay? The atomic mass is gonna be the helium, most popular, right? The second lightest element in the planet Earth or the universe. It's gonna be helium is 4 gram atom is the atomic mass, atomic weight, right? And then I'm gonna take beryllium, right? Beryllium is 9.012, 8 gram per atom. Only 2 for noble gases. You get the point? And then I forgot to stress out also that, in group 1A, we have also barium, right? Together with a sodium. Barium, for example, barium hydroxide, if you try to react that with the hydroxide, okay? So barium atomic weight is like this, 137.327 gram per atom. Okay? Like that. Diba, mga palangga? Okay? And now we go to the, shall we say, group 7A. It's gonna be like, group 7A, right? The halide family or the halogen family. Okay? Like that. So, halogen or halide. Okay, parihan na siya guys ha. Halogen, halide family. But, you will say halide if it is existing as a polyatomic anion or anion. Let's say chloride, fluoride, bromide, okay, iodide. What else? Astatine. Astatine is not common. Only chloride, fluoride, bromide, and iodide. Astatine is not common, but most of these halides will react to an acid or the H plus. So we have hydrochloric acid, hydrochloric acid, hydroiodic acid, okay, like that. And then hydroacetic acid. It's not common, but it's possible because they belong to the same group 7A, meaning 7 electrons in the outermost shell. Okay, like that. Okay, they will react to acid, but normally, it's okay, but you cannot say that it will react all the time. See, you will never say fluoride hydroxide, there's no such like that, okay? Yes. Bromine hydroxide, there's bromine hydroxide half, and then fluorine hydroxide. It depends on the situation. Just go to your review to your general chemistry lecture, because sometimes if it sounds awkward, meaning it doesn't exist, but we should not believe in that concept, because sometimes it can be, right? Especially the ionic compound. Ionic compound, non-metal and metal. Okay? Ionic compound. So that's a halogen or halide family. So that's halide, if negative one. For halogen, it will exist as a diatomic pure substance. Let's say chlorine Chlorine gas, like this. Fluorine gas, bromine gas, like Br2, F2, Cl2, I2. So these are now halogen, okay? Like that, but it will exist as a gas also. Wow, right? The atomic. Then if you try to have only chlorine, okay, then no need. It's only for the purpose of balancing the chemical equation or determining the amount of a substance in a compound. You'll say chlorine. Okay. For example, I will determine chlorine in, for example, in hydrochloric acid. You'll never say I will determine chlorine gas because the gas will escape to the atmosphere. You cannot hold. I will say you can get the chlorine like that. Okay, so sobra, pollution gas and at the same time solid also. Okay, or sometimes liquid. Okay, better to see in the chemical laboratory their appearance to make sure. But that's based on theory. Chlorine gas, which is a gas, and then chlorine, it could either be a solid or a liquid. Okay, get the point. Okay, so now we go to the atomic masses or atomic weights. So we have for fluorine. Fluorine has the lowest atomic mass, atomic weight of all the halogen group or halide group. So we have 19 grams per atom for fluoride of fluorine. Okay, 19 gram atom. So we need to do this in ascending order for the halogen group. Then we have chlorine, 35.45 gram atom. We have the bromine, we have 79.90 gram atom, and we have the iodine, 126.9 gram atom, and we have the astatine, this is 210 gram atom. So if I will say, which of the following has a higher reactivity and the highest boiling point? Okay, so you will think, the molecular weight. Okay, so if the molecular weight will increase, take note guys, the molar masses or the atomic number also will increase and the mass number. So meaning to say, atomic number, atomic AN is directly proportional to the mass number and directly proportional to the reactivity and directly proportional to the boiling point. Okay? Like directly proportional to the molecular weight or the atomic mass or the molar mass, something like that. Okay? So too much. Okay? So meaning to say from left to right in the periodic table, the atomic number will increase. Okay? Your mass number will also increase. Okay? Your boiling point will also increase, something like that. And also your molecular weight will also increase. Okay? Or atomic mass will also increase. Now, from top to the bottom, same story. Atomic number will increase. Okay? Molecular weight and atomic mass will increase. Boiling point will increase, something like that. And also the reactivity will increase. It's very easy to detect because always increase, okay? So for the electropositivity and electronegativity will matter. So what you try to understand for that is metals and non-metals. Okay. Okay. Let's go back to the basics. Okay. Most of the metals are electropositive metals. Metals, electropositive. Okay. Okay. So usually they will give off will share electrons. Okay, like that. And then non-metals are electronegative. Okay, so mostly they will accept the electrons. Or if they accept the electrons, they gain the electrons. Or they receive the electrons. While these metals are continuously giving the electrons. Why they give the electrons? Because they have more electrons. Okay? With themselves because that is positive. Positive is more than negative. Okay? Like that. So that's the theory behind. So like this. Okay? So if that we have a theory, electropositivity and electronegativity. So meaning to say that from less, okay, you get the point. The more it will become non-metals, and then reverse will do. Okay, so meaning to say highly electronegative elements are in the right corner. Okay, the gases going there, and the halides, halogens, noble gases, blah blah blah, chuba chub chub. Okay, and then the more metallic part will be here in the left. Okay, and then there will be in between on the middle part. So these are transition metals. Okay, transition. Okay, they have two or more charges like that. That's why transition. Okay, so we have the atomic mass of the halogen and halide group. Okay, with the point. And now we go to the most common all the time. Okay, like this. Guys, I'll never memorize the radioactive elements. I only memorize one because not all the time will be, presented in the problem. Only in the nuclear transmutation topic in nuclear chemistry. It deals with radiation and radioactivity. Radioactivity, right? Okay. Okay, X-ray is discovered by Roentgen, right? X-ray discovered by Roentgen. And then radioactivity is discovered by Marie Curie. Okay, I will write. Okay, okay. X-ray discovered by Roentgen. Okay, and this X-ray is also known as a gamma ray, right? Gamma ray. So like that. Okay, it's used in the hospital to determine if there are spots for the tuberculosis or whatever in your respiratory, then you undergo the chest X-ray, respiratory X-ray, something like that. Okay, so that principle is covered by Engr. Okay, that's what I remembered in my first year college. Oh, high school. Okay, now in the radioactivity, it's gonna be very, very theory, right? Correct me if I'm wrong. Radioactivity. Theory, Marie Curie. Ganon. Diba? Okay. Correct me if I'm wrong, mga palangga, ha? Okay. So, ganon. And then, so, uranium. Uranium is a radioactive material or element. And then, it has an atomic mass of 238. Okay? 238 gram per atom. Actually, we have also cesium. Okay? Cesium, iridium. Okay, let's say plutonium. Right? Plutonium. And the rest. Iridium, cesium, plutonium, uranium. Okay, I don't think so with radium. Radium is radioactive, I forgot. You get the point. It ends usually IUN. Okay? Like that. Except for the polonium. Polonium is not radioactive, plutonium only. Okay. Like that. Okay? So, right? Only one I memorized for radioactive element, right? Okay. Now we go to the most common, which are the carbohydrates. Okay, carbohydrates and protein. So carbohydrates, CHOs, right? CHO. And then protein is CHONS. So the common is the CHO, right? Let's go first with CHO. Carbon, 12 gram atom. Hydrogen, 1.008 gram atom. Oxygen is 16. Then nitrogen. Nitrogen is 14 grams atom. And sulfur is 32 grams atom. Okay, class. Carbohydrates and protein class. Okay. The same with sugar. Sugar is basically the same with carbohydrates, right? Now we go to the metals. Okay. So metals. Metals are good conductor of electricity, and it has properties of being ductile, malleable. What else? I forgot, guys. Luster, meaning it will shine, something like that. And then the nonmetals will be the reverse. Okay, the nonmetals have a poor conductor of electricity, like that, and get the point. So, and then more of them are insulators, something like that. They will never conduct electricity, of course. Okay, and then have lesser thermal conductivity. Lesser thermal conductivity meaning higher resistance, right? Okay, and then what else? There are brittle, something like that. Okay, okay. So, one of some properties of metals and non-metals. Now, ano sa metals model? Okay. Now, first, we need to introduce to you guys the most popular copper. Okay, copper. Copper is 63.55 gram atom, right? Copper, right? Very common. So in metallurgical engineering or in the what you call mining engineering, right? Okay, we have zinc 65.38 mga palangga. Okay, ganon. And then we have also the cobalt. Cobalt is 53.93, something like that. Okay, this for the cobalt, mga palangga. So, if you have the cobalt, you have also the nickel. Oh my gosh. We have 58.69 gram per atom. Okay, now we have also for chromium. Okay, chromium is gonna be 52. So lead is the copper, right? Okay, so 207.2 gram per atom. Naging maklaro, guys? Sa lead. So these are very, very useful during our calculations, in the reduction oxidation topic. Okay? Hello mga palangga. This is your instructor. Artificial instructor, oh my gosh. Artificial. Okay. Artificial, okay. Get the point? We have lead. Wait. Di ba klaro siya, guys? Lead. Oh, ganan. So, 207.2 gram per atom. Okay? And then, we have the mercury, Hg, 200.6 gram atom. Okay? Like that. Okay? And then the most popular, oh my gosh, this element is an identification that you are also rich in a jewelry. Okay? This is gold. Okay? Au. Okay? Au has 197 gram atom. Atomic mass and atomic weight. Okay? For gold. And also, oh my gosh, is this expensive or not? Not really, right? Silver. Silver Ag is 107.9 gram atom. Okay? And now we have cadmium. Cd is equal to 112.4 gram atom. And we have the iron, 55.85 gram atom. Ganan. And then we have also the most popular in the Earth's crust, silicon, Si. Okay, the main component of silica. Okay, silicon is, we have 28.28, right? Correct me if I'm wrong, mga pananda. Okay, like that. You get the point, mo na siyang mahitabo. Okay, we have phosphorus, 30.97 gram atom. Okay? Ganon. Okay. What else? We have also the bismuth. You know bismuth? Okay, the bismuth is I think in the transition, but more on the right side, going to the right. Okay, but still metal, right? Bismuth is gonna be ano siya, 208.98 gram per atom. Bismuth. We have polonium, 209 gram per atom. The astatine is counted in already, like I mentioned. Okay, like that. See what else? Okay. I already mentioned everything about the common, right? The zinc, the nickel, the blah, so and so. What else? I think it's kalas, right? So what are those common po siya talaga? Okay. I think I did not mention palladium. Okay. What else? Strontium, iridium. Iridium is radioactive. That would be enough, right? That's too much already, right? You get the point. Okay. So that's enough. So with that, we can really name the compounds or any mixtures or whatever. Get the point. Ganon. So these are the elements, atomic mass and weight. Okay. So correct me if I'm wrong. If there are errors in the point something. Okay, because I am not perfectly memorizing the point something, the last two digits of the atomic mass, atomic weight. So sometimes if I forgot also, I will refer also to the books, to any other reference materials, and sometimes I will also use Google search to, to prove, to confirm that I am wrong or not, confirmatory. Okay, but the first thing, the first step is really relying on my stock knowledge and acquired knowledge. Okay, thank you so much for watching this elements, atomic mass and atomic weight. I hope you enjoy a lot, alright? This is your science vlogger. I am a singer, eternal voice, Sotero. Bye bye, God bless everybody. I hope you will subscribe to my channel, and you can also comment or like or even share if you want also, and click the bell notification for some news updates of my expertise in vlogging, which is really chemistry, my guys. Okay? Bye bye. God bless everybody. Kaloka.